let's find the row echelon form of the matrix, then solve. Got to show every step, which means we're doing Gaussian elimination, I think it's pronounced. So when we're doing this, in order to get it into row echelon form, the goal is to get the bottom left corner of our augmented matrix here to be all zeros. So in that triangle, I want it to be like 0, 0, 0. Then on this diagonal right here, I want all of those to be ones. So I want 1, 1, 1. That's going to help us to go through and solve for each variable. What's interesting about row echelon form is that they're not all unique, meaning the steps that I do to get row echelon form might be different from your steps, which could result in a different matrix in the end. But our solutions will be the same. So the solution is unique. So if you might do different steps here, and that's okay. This is just what I think about when I do it. So going through this, first things first, we got to make sure if you're given a system of equations, you put them into an augmented matrix, which is what I did here, right? Taking those coefficients and transferring them. Then what we're going to do is we got to do our row operations. And with our row operations, we got to say what we're doing with each step. So for me, what I'm going to do is I'm going to start right here, trying to get rid of this 4. So I'm going to do row 1, row 2 minus row 1, because they're both 4s, and I'm going to replace row 2. So with the elementary row operations, the ones that are allowed is we're able to go through and add and subtract rows from each other. As long as we're doing the entire row, we can multiply a row by a non-zero number, and we can like shift where they are in the matrix. So if it's the 3rd row, we can switch places and put it in the 2nd row instead. Other than that, that's all we can do in order to go through and try to eliminate some of these variables. So let's go ahead and give this one a try. I'm replacing row 2, which means everything else is going to stay the same. Got 4, negative 4, 4, negative 4. This one is going to become a 1 because that's what I'm, what else becomes 0. So I'm trying to eliminate it. Then I got 2 minus negative, or 1 minus negative 4, which is going to give me 5. Then I got negative 2 minus 4, so negative 6. And then 5 minus negative 4, which is 9. And then row 3 stayed the same. So make sure when you're doing this, you're doing just one operation at a time. And then let's go ahead and do another one. So I'm going to keep going to the right. Now, you know what I want to do? I want to get a 1 right here so that I can easily zero out this one on the bottom. So in order to do that, I'm going to multiply row 1 by 1/4, and I'm going to replace that first row. So all I'm doing is dividing everything by 4, so that'd give me 1, negative 1, 1, negative 1. Row 2 stayed the same, row 3 stayed the same. Negative 4 and negative 16. All right, up next, what I think I want to do is I want to get this bottom one here to be 0. So in order to cancel out that 3, with only using our elementary row operations, well, what I can do is I can take row 1, multiply everything there by 3, and then add it to row 3. So bring it down here. I got row 1 times 3. Add that to row 3, and then replace row 3. Everything else stays the same. 1, negative 1, 1, 1. All right, so then I got 0 here because we're purposely canceling. Negative 1 times 3 is negative 3, plus negative 3 gives me negative 6. Okay, do that process again and again. I get negative 1 and negative 19. Making moves, okay. Keep it going, keep it going. I need a 0 right here. So, well, what we could do is, well, I want to make sure I use the row that has 0 here, and there's no way for me to easily multiply and cancel there. So I'm going to get a 1 right there first. Right? Sometimes it's easiest to get the 1 first, so let's do that. Here's where it gets a little messy. We got some fractions. So I'm going to do 1/5 times row 2 and replace row 2. Right? Again, you might do this in a different way, but this is just what I'm noticing as I'm going through this one and how I would do it. So then divide everything by 5. I got 0. That turns into a 1. This would be -6/5. This would be 9/5. So I would keep it as fractions. It's going to make it easiest, even though you are going to have to mess with some common denominators. But let's go ahead and do this. So now, when eliminating this -6, I just have to take row 2, multiply by 6, and then add it to row 3. So 6R2 plus R3, and I'm going to replace row 3. So 1, -1, 1, -1, 0, 1, -6/5, 9/5. And then, hopefully I did this correctly. I think I got 0, 0. So we purposely canceled that one out. And I got -41/5 and -41/5. All right. Oh my gosh, almost there. I just need one more 1. I'm going to put a 1 right there. And in order to do that, let's multiply by the reciprocal. So I'm going to do -5/41 times row 3, replace row 3. All right. 1, -1, 1, -1. 0, 1, -6/5, 9/5. And then 0, 0, 1, 1. Now that we have this, we can go through and put it back into our variables and solve. So this was R, S, T, and then the answer, the number, right? So that means that we know T equals 1. And S minus 6/5T equals 9/5. And then we know that I got R minus S plus T equals -1. Right, just going back through, taking my augmented matrix, putting it back, right, our coefficients, that's where I'm getting the numbers next to the variables there. So let's go through and solve. From here, we got to do some substitution. If I know that T equals 1, well, then I can use that, solve for S. S minus plugging in 1 for T, 6/5 equals 9/5. Adding 6/5 to both sides, we get S equals 15/5, which is 3. Okay, that's a good sign. Now we can plug those back in for S and for T. So we got R minus 3 plus 1 equals -1. Okay, -2, R minus 2 equals -1, which means R equals 1. Our final answer, I like it when it's written as a coordinate. So R comes first, 1, then S, we got 3, then T, which is 1. And that right there is our solution.